You're watching part 3 of Forensic Tracking, or the Science of Forensic Flow System Analysis. I'm Willem Larson. As you remember in previous videos, we're looking at tracks and gates as flow systems. Flow systems are comprised of both laminar and turbulent flows. Laminar flows are smooth, wave-like. Turbulent flows are choppy, churning, branching, and fissuring. The natural baseline human gait and animal gait is a carrier wave for biometric and environmental data generated by the resistances that the body experiences. A gait is nothing more than the rhythm, spacing, and orientation of footfalls. A gait can be a walk, a jog, a run, a gallop. Smooth laminar gaits generate smooth laminar tracks. They are a sign that the gait itself is carrying the energy generated by the animal body efficiently and effectively forward. This creates a laminar waveform, and laminar tracks are generated in the troughs of that waveform. On the other hand, a turbulent gait will do the opposite. It means the gait is unable to effectively and smoothly carry the energy generated in the animal body forward, and this is reflected in the track. A track itself is a waveform, just like the gait. The horizon, wall, and floor of a track comprise the peaks and troughs of that waveform. Now, in this example, something has caught our subject's attention. They have stopped and looked to the right. This change in behavior has modulated the waveform of their gait. It was once a walk, now it is something else. If we look at it differently, we can see that turbulence has entered the waveform. Events, resistances, stimuli that affect animals and humans can be looked at as generating this turbulence. Now it's quiz time. In this photo, you'll see track 1 above and track 2 below. Both were made within minutes of each other, but both are made from completely different gaits on completely different track lines. In fact, one is a slow jog, one is a fast walk. Now, the only thing these two tracks have in common is that they have the exact same stride length. That's right, the slow jog was slow enough that it has the same stride as the fast walk. Let's look closer at track 1. Here's a simplified drawing of the waveform generated in track 1. You'll see that the heel strike is towards the right of the picture. DOT indicates direction of travel. The foot is rolled forward and generated a large amount of mounding and depth towards the front of the track as it is pushed off. That is track 1. Track 2 is quite different. It's a lot shallower. There's not that large mounding, and yet there is depth in the ball, which is towards the left of the cross section. And there's a little shelf between the ball and the toes as it moves out of as the foot moves out of the track. So, between track 1 and track 2, which is a fast walk and which is a slow jog? If you want to try and guess, pause the video now. In just a few seconds, I'm going to move right into the answer. All right, here's your answer. The track at the top of the photo was the fast walk. We know that because a fast walk is inefficient at generating enough energy to maintain that stride length that overlaps with the slow jog. In each track, the track maker had to push off, thus creating the mounding towards the middle rear of the track. The slow jog had the opposite problem. In order to slow down this efficient stride enough, to shorten the stride length to overlap with a fast walk, the slow jog actually had to brake, thus creating the deep ball and the shelf effect towards the front of the track where the braking forces were applied. Once again, look at the photo. Above is the fast walk, where in each track, the track maker had to push off to extend that stride. Below is the slow jog. Now, if you were surprised or maybe guessed correctly, but still didn't quite understand why you were right, I hope you're inspired enough to continue with us into part 4.